Okay, so let's take a look at number 36 on page 509. A bowling ball with a mass of 6 kilograms rolls with a velocity of 1.2 meters per second, so v of the ball initial, 1.2 meters per second, towards a single standing bowling pin that has a mass of, so the pin, 0.22 kilograms. When the ball strikes the bowling pin, the pin flies off at an angle of 70 degrees counterclockwise from the original direction. So here's the original direction, so the pin is going up this way. Okay, this angle is 70 degrees. And it says it has a velocity of 3.6 meters per second. So v of the pin final, 3.6 meters per second. Okay, and if the pin's going that way, then we know the ball must be going this way. So this will be v of the ball final, and this will be the theta. The pin has an x and a y, v of the pin fy, v of the pin fx, and of course the ball does too. V of the ball fy, v of the ball fx. So, and it wants to know what is the final velocity of the ball. All right, so if you start with your x direction, it'll be m of the ball, v of the ball initial, x plus m of the pin, v of the pin initial x will equal m of the ball, v of the ball final x plus m of the pin, v of the pin final x. The pin's not moving to start with, so this goes to 0. The ball is only moving in the x direction, so this is really just m of the ball, v of the ball initial. You're looking for this vbfx, so bring this guy over. So minus m of the pin, v of the pin final, and the x component is going to be the cosine. So cos theta is equal to v of the ball final divided by m of the ball. So you can fill your numbers in. V of the ball final x will equal 6 kilograms times 1.2 meters per second minus 0.22 kilograms times 3.6 meters per second. There really is a decimal there. Times the cos of 70. And then do not forget to divide by the 6 kilograms. So you get v of the ball final x to be 1.155, I believe. 1.155 meters per second. Works out to be positive, so it's going in the original direction. Now we do our y. So m of the ball, v of the ball, initial y, plus m of the pin, v of the pin, initial y, will equal m of the ball, v of the ball, final y, plus m of the pin, v of the pin, final y. But neither of them moving initially in the y direction, so these are both 0. So bring over one term, so it'll be m of the ball, v of the ball, final y, which is what we're looking for, equals negative m of the pin, v of the pin, final, and the y component will be sine. And then divide both sides by the mass of the ball. So v of the ball final y equals negative mass of the pin, 0.22 kilograms, times 3.6 meters per second, sine of 70, divided by 6 kilograms. And you get v of the ball final y to equal negative 0.124 meters per second. Okay, so if we go up here, I'll just redraw it here. The negative, of course, means going in the opposite direction. Pin was going up, so this will be going down. So this one is 1.155 meters per second going this way, and this little guy, 0.124 meters per second. So this is v of the ball final. And so when you do the math, you get 1.161 meters per second, and you get it to be an angle of 6.13047, and that's going to be clockwise original. Okay? There you go. That's number 36. Number 37 says, a car which is 1750 kilograms traveling due south. So I have one car traveling due south. Its mass is 1750 kgs. And a car 1450 is traveling due east. So here's my second car. This is A. This is B. This guy's going east. MB is 1450 kilograms. Except I just did that west, didn't I? Shoot. Like I was saying east. And this mass is 1450 kilograms. All right, so they're going to collide. Okay, so they're going to collide here and get stuck together. And it says the cars lock together and move off at 35.8 kilometers per hour. Okay, so V final is 35.8 kilometers per hour. And the angle is east 31.6 degrees. So in here, 31.6 degrees, and that's east-south. So it's going to have a V final X component and a V final Y component. Now you might think this one's harder, but this one's actually easier. So if we start with our X direction, it'll be MAVA initial X plus MBVB initial X is equal to, and after they join together, so you can just write them as MA plus MB V final X. Well, if you look in the X direction, A isn't moving in the X direction. This goes to 0. And B is only moving in the X direction. So it really is just VB initial, which is what you're looking for. And it's equal to MA plus MB. And V final X is going to be cosine. So V final cos theta divided by MB. So VB initial is going to be equal to 1750 plus 1450 times, and you don't need to change this, like they gave it to you in kilometers per hour. You are certainly able to get a speed in kilometers per hour. Cos of 31.6, and then it's divided by the B. It's divided by 1450. So VB initial should be, oh, I don't know if I even have it written down. Something that I'll have to type in a minute. And that's the final for VB. So 1750 plus 1450 divided by 1450 times 35.8 times 31.6 cos. So you get 67.2923. I can't imagine. Maybe. Kilometers per hour. And that would be east. Okay, and now you're going to do A. So you're going to do the Y direction. So MAVA initial Y plus MBVB initial Y equals MA plus MB V final Y. Well, the B is not moving in the Y. The A is totally in the Y. So it'll be MA plus MB. V final Y is V final sine theta divided by MA. So VA initial will equal, oh, it said it was going north? No, it was going south. I didn't screw that one up. 1750 kilograms, 1450 kilograms, 35.8 kilometers per hour, sine of 31.6, this time divided by 1750 kilograms. So in a way, it actually is easier because 1450 plus 1750, going to run out of time, divided by 1750 times 35.8